Alright, problem number 4. Find the number of degrees in the positive difference between the sum of the measures of the 5 acute interior angles and the sum of the 5 obtuse exterior angles of the 5-point star. Okay, so we're trying to find the difference between two things. One is the sum of the measures of the 5 acute interior angles, and the other is the sum of the measures of the 5 obtuse exterior angles. Okay, so where are those? Here's a 5-point star, and actually I think I'm going to make this a little bit bigger so that we can see what's going on a little better. Okay, so I'll make that a little bigger. I'll switch back to a pen. And okay, so the sum of the let's figure out where these 5 acute interior angles are. Obviously, those are these, right? So let's label them. Let's just call this angle A. Let's call this one angle B, C, D, and E. Okay, those are the 5 acute interior angles. All right, and the 5 obtuse exterior angles then are what? Let's pick up where we left off. So here's an obtuse exterior angle. That's one of the angles that they're talking about. And so let's just call this F. We'll call this G. We'll call this H. We'll call this I, and we'll call this J. Oops, that's supposed to be J. And so here is what we're supposed to find out. The positive difference between the sum of the A, B, C, D, E and the F, G, H, I, J. Okay? And I know that we have 5 obtuse exterior angles, so I know that that sum is going to be bigger because an obtuse angle is greater than 90 degrees, right? So these are going to be bigger angles. So I'm actually going to write it as F plus G plus H plus I plus J. Okay, so that's the sum. That's the second thing here, the sum of the measures of the 5 obtuse exterior angles. And we want to find the difference between that and the sum of the acute interior angles. So that'll be A, oops, that looks like an H, A plus B plus C plus D plus E. Okay, and that should give us a positive number because I know that these 5 angles are obtuse and these are all acute. Okay, so acute angles are less than 90 degrees and obtuse angles are greater than 90 degrees. So, given that, let's see what we can figure out. Now, the first thing I thought of when I saw this problem, my son used to work with this program called Logo back when he was a kid. Oh, that's not good. I meant, let's see, I'm going to undo that. Undo move. Okay. He used to work with this program called Logo when he was a kid, and it had this little turtle. And had this little turtle that sort of looked like this with a head and some legs, and you could program it to make it draw things. So as it walked along, it would leave a line. Okay, so you know, if you wanted to leave, you know, I think maybe it was facing this way at first, and if you wanted it to draw a line, you'd tell it to go forward by, you know, so much distance. And then if you wanted it to draw a square, you would tell the turtle to turn 90 degrees and then go forward, you know, and then turn 90 degrees and then go forward, and then so on, you know, turn 90 degrees and then go forward. Oops. Alright, and so you quickly learn that in order to make a closed polygon, you end up having to turn this turtle by 360 degrees. Okay, so here we go, 90, 90, 90, and then again, well, I guess if you want to go back to facing the original direction, then it's 90. So you have 4 90-degree turns to get back to where you were to begin with, and so you end up going 360 degrees. And the same thing for a triangle. If you wanted to draw a triangle, you would tell your turtle to go forward and then turn what? It would turn 120 degrees. And then it would come up here and it would turn 120 degrees. And then to get back where you were, you turn another 120 degrees, right? So a total of 360 degrees. And so the more sides, you just divide 360 by the number of sides and you get the number of degrees that you have to turn. And there's a theorem in geometry that says that the sum of the exterior angles is 360 degrees for any polygon, right? So if you wanted to make a 10-sided figure with this turtle, you would go forward and then you would turn 36 degrees. And then you would turn another 36 degrees, and that's 36 degrees from the original direction, so it's this angle. So it's the exterior angles, okay? So how does that relate to this? I know that if I was drawing this 5-point star with a turtle in logo, what would I have to do? Let's say that the turtle starts here, okay? So he's originally facing, let's say, this way. And so I want him to turn a certain number of degrees, and so now he's facing this way. He draws a line, and then okay, so he's facing this way, and so then I want him to turn this way. Okay, it's the opposite direction of this. All right, so let's call counterclockwise. We'll call that positive, and if we turn clockwise, we're sort of undoing this direction. So we're going to call that negative rotation. Okay. And okay, so you can see the turtle, turns some degrees, walks forward, turns back, walks forward, and he's facing this direction, and he turns this way, and walks forward. He's facing this direction, so then he turns this way. And he's facing this direction, so then he turns this way, and okay, so then he's going this direction, and he turns this way, walks forward, he's going this direction, and then he turns this way, and so on. He's going this way, and he turns, and then he's going this way, and he turns, and he's going this way, and he turns. And then finally he gets back here to where he started. Okay? So, in order to do that, to get back to where you started, no matter what you're drawing, you have to turn a total of 360 degrees. Okay? So, that's kind of the program is called Logo. I think it was developed by MIT, but there's a number of different I think you can even get it online for free. You may not be able to save your programs, but it's kind of a cool thing to work with. Not only do you learn program, but you learn a lot of geometry from it. So, all right. Well, how does this relate? Okay, so we want to draw a closed figure. We want to draw this closed star, and so if we're originally going in this direction, let's say at A, and then we turn a certain number of degrees. Now, what is that degrees? Now, we know if the angle that we want to work with is A, the acute interior angle, but this is essentially 180 minus A, okay? So our first turn is 180 minus A, okay? So that's our first turn. That's this angle that we turn here. And then we're going this direction, okay? And then we turn back. And so now we're turning in the negative direction. So we're undoing the other turn. So I'm going to make this a minus sign. And the angle here is 180 minus F, okay? So you see that if I added this turn here plus F, I get a straight line, right? So that's 180 minus F. So 180 minus F. Alright, then I come up here and I turn, and the angle here is going to be 180 minus B. Okay, now we're going in the positive direction, so let's add that. 180 minus B. And then we get here, we turn in the clockwise direction, which is our negative reference. So we're going to, what? We're going to turn by 180 minus G. Alright, so let's keep going. I'm going to kind of continue it over here. Alright, so now we're up to G. Now we get to that angle C, and we're going to turn in the positive direction, 180 minus C, and then we turn back, and we go 180 minus H, right? So we're here, and we turn, we're here, and then we turn here, and then we get down here, and we turn 180 minus D, and then, okay, I gotta keep going here. Okay, so we're at D, then we're at I, so we gotta turn 180 minus I in the clockwise direction, so that's why it's negative. Alright, let's keep working. So 180 minus E, because after we turn here, we travel forward, and then we turn back at E, and okay, and then we get to the I, or no, that's right, that's J. That's supposed to be a J, isn't it? J. And so then we get to I, we turn in the clockwise direction, 180 minus J. Okay, and then we're facing. If we go forward, then we end up where we were to begin with. All right, does that make sense? So let's simplify this. I think the first thing I want to do is, I've got the negative of this thing, so I'm going to actually I'm going to distribute the negative signs. Okay, so if I, like, here is a negative 1 times this whole quantity. All right, so I'm going to negate the 180 and make the negative a positive. Okay, in the same way here. Oops, and I want to, if I make that a positive, then this becomes negative and this becomes positive. And then make this positive, make that negative, make that positive. And here, make that positive, make that negative, and make that positive. Okay, so I'm just distributing the negative sign inside so I can work with all positive numbers. And the positives, I can take away the parentheses now. That's the key here. If I that's why I'm doing this. So I can take away the parentheses, and then I can rearrange the numbers. Okay. So so what I'm seeing here is that here we have like a positive 180, and now we have a negative 180 here. So those are going to cancel out. Okay. And then we have another positive and another negative. Those are going to cancel out. Those are be 0. And positive 180, negative 180. Those are going to be 0. Positive, negative. Those are going to be 0. And this one too is going to cancel out. So all those 180s go away. And now I'm going to rewrite this thing. Okay. I want to group that. I want to find this. Oh, and one thing I did. This whole thing, I said to get back to where you were starting from, you have to go a full 360 degrees. So I know that this has to be 360 degrees. Okay, if I think in terms of my turtle drawing this star. Okay, so let's then, we got rid of all these constant terms, all these 180s. So I'm going to write the positive terms first. Now A is negative, so F is my first positive term. B is negative, and then I have G. C is negative, then I have H. D is negative, and then I have I. And then E is negative, and I have J. Okay, I'm actually going to write it like that. I'm going to put parentheses in it because I want to be able to compare it to this. Okay. And then I can actually I could write this as minus A, minus B, minus C, minus D, minus E, but But I'm actually going to take